I've got two quadratic functions up here in standard form, and I'm going to try to graph both of these without completing the square to put into vertex form. So the directions for both of these, I'm going to find the vertex and the intercepts and graph the parabolas. Now, on quizzes and exams, if I just gave you a quadratic formula and I asked you to graph it, finding the vertex and intercepts, you can use any legitimate method. So you can choose which method you prefer. However, I reserve the right to tell you that you have to do it by completing the square to put things into vertex form. The reason for that, we've got a nifty shortcut to avoid completing the square, and I like that. That's usually my preference. But just because there's a way around completing the square for this type of problem doesn't mean there's always a way around completing the square. That's a useful skill that you want to take with you into calculus. So I may require that you practice that skill. So when you're doing the homework, follow the directions, do the problem as they tell you to do it. On exams and quizzes, read the directions carefully. If I specify a method, use that method. If I don't, you can choose. All right, so let's do f of x first. I'm just going to write down my a, b, and c. I know I'm going to need a and b to find the vertex, and if I end up using the quadratic formula to find x-intercepts, I'll need c as well. So I'm just going to write them all down up front. A is -1, b is 3, c is -8. The x value of the vertex is the opposite of b over 2a. That's the nice part of the quadratic formula. That's -3 over 2 times -1. That's going to be +3/2. Now, the y value of the vertex is what I get if I plug that in. So that's f evaluated at 3/2. So I've got to plug in a fraction. Now, when you're doing the homework, you can use a calculator. Don't. If you use a calculator every time in the homework that you have to plug in a fraction, then when you get to a timed exam or a quiz where you're not allowed a calculator and you have to plug in a fraction, it's not going to go very well. So practice. That's what the homework is for. So there are occasionally times where there are very tedious calculations in the homework and you can pull out a calculator. But most of the time you should be practicing without a calculator. I might put that same problem on a timed exam or quiz where you don't have one. So very good to work through it. Okay, so we're going to have the opposite of 3/2 squared. Notice the parentheses there. Just go around what I'm plugging in, which is 3/2. So we'll square it and then make it negative. Plus 3 times 3/2 minus 8. So that's going to be -9/4 plus 9/2 minus 8, which I'll write as 8 over 1. Now to combine these, I need a common denominator. So I'll multiply that by 1 in the form of 2/2, and that by 1 in the form of 4/2. So this is -9/4 plus 18/4 minus 32/4. That will be some fourths. -9 plus 18 is 9. Minus 32 is going to give me -23. All right, so my vertex is at 3/2, -23/4. Notice that's 1.5, and that's -5 3/4. That might make it a little bit easier when it comes to plotting that point. Okay, so need a slightly smaller scale on my y-axis here. Okay, so there's 1.5. Let's see, 1, 2, 3, 4, 5, -5 3/4. All right. Now I can see this parabola is going to open down. That's because my A is negative. So there won't be any x-intercepts because that vertex is going to be a high point. So don't need to worry about finding them, but I do need my y-intercept. So I'll plug in 0. That just gives me -8. So my y-intercept is the point 0, -8. So my parabola looks something like that. I did use a slightly different scale on the x and the y axis. If you used the same scale, yours might be a little bit different looking, but should have those same points. Now, I think the quickest way of noticing that there are no x-intercepts is that the vertex is at a negative value and it's a high point. If you didn't notice that and you tried to solve negative x squared plus 3x minus 8 equals 0, doesn't factor, so you'd fall back on the quadratic formula. So we'd have x is the opposite of b plus or minus root b squared minus 4ac all over 2a. That should just roll off the tongue. So if you're not familiar with that, become friends with it soon. Okay. So there were my a, b, and c. So it's the opposite of 3 plus or minus the square root of 9 minus 4 times negative 1 times negative 8 all over negative 2. So that's negative 3 plus or minus the square root of 9 minus 32 is negative 23 over negative 2. Here's how I see algebraically that there are no solutions, is that I get a negative under that radical sign. Now, later on this chapter, we will expand to work in the complex numbers where we can take square roots of negative numbers. But that's only going to be when we're working with things algebraically, because when we're graphing, we are always working in the real numbers. This is a real number line. This is a real number line. Okay? So, if you're graphing, or just if you're working in the real numbers, you can't take the square root of a negative. All right, let's try g of x here. So, a is 2, b is negative 4, c is negative 3. So, the x value of my vertex is the opposite of b over 2a. That's going to be the opposite of 4 over 2 times 2. So that's negative 4 over 4. That's just negative 1. The y value of the vertex, I'm sorry, I said the opposite of b, and then I forgot to take the opposite of negative 4. That should have been positive 4. So the x value of the vertex should end up being positive 1. I apologize. That's a plus 1. So the y value of the vertex is just g of 1. That's 2 times 1 squared minus 4 times 1 minus 3. 2 minus 4 is negative 2 minus 3 is negative 5. So we're at 1, negative 5. Now this time, my a was positive, so I know that we're opening up. So if my vertex is below the x-axis, but we're opening up, we're going to have x-intercepts. So there's my vertex at 1, negative 5. Let's go ahead and find our y-intercept next, because that's really straightforward. If I plug in 0, I just get negative 3. So my y-intercept is the point 0, negative 3. Now, for the x-intercepts, I need to set this thing equal to 0. So I'm looking for 2x squared minus 4x minus 3 to equal 0. You can try factoring. Turns out this one doesn't factor. So I'm going to use my quadratic formula. X is the opposite of b, plus or minus root b squared minus 4ac all over 2a. So that's going to be 4. This time I did remember to take the opposite of negative 4. Plus or minus the square root of 16 minus 4 times 2 times negative 3 all over 2a will be 4. Okay. So that's 4 plus or minus the square root of these two negatives are going to cancel. So that just becomes 16 plus 8 times 3 would be 24, all divided by 4. So that's going to be 4 plus or minus square root of 40 all over 4. Let me just rewrite that up here. Okay, now when you use the quadratic formula, often there's some simplification to be done. That's because the quadratic formula always involves a square root, and you need to simplify that as much as possible. And it always involves a fraction, so you need to check for lowest terms. Okay. Now, with the square root of 40, that's the square root of 4 times 10, which is the square root of 4 times the square root of 10. I can simplify that square root of 4. That's just 2 root 10. Now, I can't simplify the root 10 anymore, but I can say this is 4 plus or minus 2 root 10 all over 4. Now, I want to see if this is in lowest terms. I need to be super, super careful. I cannot cancel those 4s, and I cannot cancel this 4 and this 2, because I can't cancel across addition and subtraction. But if there's anything that I can factor out on the top so that it's connected to the rest of the top by multiplication, I might be able to cancel. And it looks like I can factor out a 2. This is 2 times 2 plus or minus root 10 all over 4. Now I can cancel this 4 with that 2, because that 2 is connected to the rest of the top by multiplication. So if you've got addition or subtraction on the top, you always have to factor before you can cancel. Okay. But now 2 goes into 4 twice, so this becomes 2 plus or minus root 10 over 2. Okay, so I'm going to have 2 X-intercepts at these values. I'm going to have 2 plus root 10 over 2 and 2 minus root 10 over 2. So I need to know how big root 10 is. Well, if I look at root 10, let me clear some space here. If I look at root 10, when I square it, I would get 10. It's a little bit bigger than if I square 3, because that would give me 9. And the next integer 4 would square to give me 16. So I know that root 10 is in between 3 and 4. Okay. So if this were 3, I'd have 5 halves. And if this were 4, I would have 6 halves, which is 3. So that's between 5 halves and 3. Okay. Here, if this were 3, I would have negative 1 half. If it were 4, I would have negative 2 halves, or negative 1. So this is between negative a half and negative 1. Okay. So now I can go ahead and plot these. So we're going to be a little bit smaller than 3, but bigger than 2.5. That gives me the point 2 plus root 10 over 2 comma 0. And here, we're going to be not quite all the way to negative 1. Past negative a half, but not quite at negative 1. That gives me my 2 minus root 10 all over 2 comma 0. And then I can connect the dots. And so there's my lovely parabola. Okay. So there is a decent amount of algebra involved when you use the quadratic formula. I'll be reviewing that as it comes up in class. If any of you feel like you need to just take some time out and spend some time focusing on that, let me know. That's something I'm happy to spend time with you on in office hours.